Have you ever really stopped to think about what happens when you type a web address into your browser and hit enter? I mean, it feels totally instant, right? But what's actually happening is this incredible global journey, all powered by an invisible engine that runs our entire digital world. Today, we're going to pull back the curtain and take a look at how that engine actually works.
And we're going to explore all of it by trying to answer what seems like a really simple question. We all know websites have names, like example.com, but they also have these number-based IP addresses. So the question is, can you just skip the name altogether and go straight to the website using its IP address?
Well, the short answer is, yeah, sometimes. But the real answer, that's where it gets so much more interesting. Because when you dig into the why, you start to uncover the fundamental rules and protocols that literally hold the modern internet together. Okay, so let's start by breaking down that question and peeling back the very first layer of technology that's at play here. To figure out why a simple name is so important, we first have to understand how the internet even uses it. And honestly, the best way to think about it is to picture a massive, planet-sized phone book.
And that brings us to our first huge concept, the domain name system. You've probably seen the letters DNS. You can just think of it as the internet's phone book, and it is the very first stop on literally every online journey you take.
DNS really only has one primary job: to translate the human-friendly domain names that we all type and remember into the numerical IP addresses that computers need to actually find each other. Right? I mean, you don't remember the phone number for everyone in your contacts, you just search for their name. DNS does exactly that, but for the entire internet.
So when you ask for a website, your request goes on this little journey. It's kind of like a multi-step dance. First, your computer asks a local recursive resolver for the address. If that resolver doesn't know, it goes up the chain to a root server. That server then points it to the right top-level domain server. That's the one that handles all the .coms or .orgs. And then finally, that TLD server points to the domain's own authoritative server, which is the one that has the final answer and gives back the IP address.
So how many of those super important root servers are there at the very top of this whole system? You might think there are thousands, but you'd be surprised. There are only 13 logical root server addresses for the entire world. Just 13.
But here's where the internet's design gets really, really clever. Using a technique called Anycast, those 13 logical addresses are actually mapped to over 1,900 physical servers. This creates this incredibly resilient and fast system, making sure a root server is always close by, no matter where you are in the world.
Okay, so our browser found the IP address. The phone book lookup is done. We should be finished with the name now, right? Well, not quite. As you're about to see, that name is about to become critical all over again. And here is the crucial point, the thing that changes everything. The domain name gets used twice. The first time is for that DNS lookup we just talked about, but it's used a second time inside the actual request your browser sends to the server after it has the IP.
And this is exactly why it matters so much. When your browser sends its request, it includes this little piece of information called a host header. If you use the domain name, that header says, hey, I'm looking for www.example.com. But if you just use the IP address, it says, hey, I'm looking for 192.0.2.1. That tiny, tiny difference in the request changes everything.
So why? It's because of a concept called virtual hosting. Here's a way to think about it. An IP address isn't a single house. It's a giant apartment building. It has one street address, but inside there could be hundreds of different apartments, or in this case, hundreds of different websites. The host header is like the apartment number. It tells the server which specific website you're there to visit. Without it, the server has no clue where to send you.
So what happens when you show up with just the building's street address but no apartment number? Well, you'll probably get sent to the lobby, which is like a default website, or you'll just get a plain old error. And even worse, because all modern security certificates are tied to the domain name, not the IP, your browser will almost certainly throw up a big, scary security warning.
Now, all of this might just seem like nerdy, low-level technical stuff, but the consequences of these systems failing are absolutely massive. To really understand the stakes, let's look back at what happened in 2021, when one of the biggest companies on the planet just vanished. Yeah, October 4th, 2021. Facebook, Instagram, WhatsApp, the whole family of apps just went dark. And this quote from the Cloudflare blog at the time just says it all. It wasn't just that they were down, it was as if someone had pulled the cables from their data centers all at once and disconnected them from the internet.
So how is that even possible? To understand that, we need to meet DNS's bigger, more powerful sibling, the Border Gateway Protocol, or BGP. Look, if DNS is the phone book that matches names to addresses, BGP is the GPS of the internet. It's the system that lets entire networks announce their routes to each other, basically shouting to the rest of the world, "Hey, here I am, and here are the paths you can take to reach me."
And this timeline just shows you the catastrophic chain reaction. At 1540 UTC, a bad configuration change caused Facebook to withdraw all of its BGP route announcements. They basically turned off their own GPS signal. Just minutes later, their DNS servers, their entries in the internet's phone book, became unreachable. Why? Because the phone book itself was located in a city that had just been completely wiped off the map.
So you see, this wasn't just a server going down. By accidentally pulling its BGP routes, Facebook effectively told the rest of the global internet that it no longer existed. For almost 6 hours, one of the largest platforms in the world was completely gone because the very systems that map out the internet had lost its address.
And all of this brings us to the final, and I think most important takeaway. These things we're talking about, DNS and BGP, they aren't just technical protocols. They are the internet's central nervous system, quietly and constantly making our entire connected world possible.
An analysis from Enterprise Times put it perfectly. DNS isn't optional plumbing. It's the connective tissue of modern cloud-based applications. It's not just a utility. It's the very fabric that links everything together, from the biggest data centers to the little app on your phone.
At the end of the day, systems like DNS and BGP are the bedrock of digital trust. They are what allow your security certificates to work, they're what make sure your email actually gets to its destination, and they validate nearly every single interaction you have online. They are this invisible but absolutely essential layer of trust and identity.
And that's the thought I really want to leave you with. That Facebook outage was a massive wake-up call. It was a stark reminder that the internet's foundations, which we all take for granted every single day, are an incredibly complex and sometimes very fragile system. It showed us how one single point of failure can cascade globally. And it really makes you wonder, what's the next domino to fall?